Hello, how's it going? I guess we're ready to get started so we get on time. My name is Ramon. Hola, I'm from Mexico. Happy to be here. I'm going to be talking a bit about myself just so you get to know who is speaking in here. I'm still an individual contributor. I'm a maintainer of a few open source robotics platforms. I come from the robotics industry, and I co-lead a few open source initiatives. On top of the open source robotics stuff, I do also the co-lead of our robotics interest group, which I will have a keynote tomorrow at 10 if you attend that. Thank you. And then what's interesting now to me, it's in the other side of autonomy into space. I'm the co-lead for the Space with Linux special interest group, which is all I will be talking about. And feel free to connect with me on LinkedIn. All right, question for everyone, like icebreaker. Anyone think space is cool? Awesome, this is the right audience. Good, we're gonna have fun. Anyone working in space right now? Less hands, that's about what I was expecting, good. Anyone planning to work on space at some point? Oh, even better, good. Yeah. Question, you don't need to raise your hands. Is Linux in space a worthwhile dream? What do you guys think? Yes? 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 Good, all right, well, the answer is no. It's actually a present reality. It's not a dream. It's happening already, and I had some examples. Anyone know? Oh, I got the names in there. Sorry. This is James Webb's telescope running Linux already. Yes, I dig that up. The biggest deployment of Linux in space, Starlink. They're hoping to get 12,000 of these in space and then expand all the way to 30,000. So like 30,000 Linux-based satellites in space. This is the Astrobee running inside the ISS. This is a robot. Ingenuity in Mars, decommissioned, but flew a long mission, way beyond the intended capabilities of the mission. Some NASA rovers, not all pictured here, running Linux. Who knows what this is? The ISS, big space. Yes, the big space lab. Well, this is a cool diagram I found online. What does it take to actually build a lab in space? Like tons of modules from different agencies distributed across the world. Much like open source, right? Like everyone contributes together, comes out to build this big project. You need a lot of standards to build this, right? Like it's not something that just came together because someone decided. It's like a lot of people came together and decided that this is the way it's going to be built. How does it look like from the inside? The reality of any standards ecosystem, it looks ugly, right? Yes. There's a lot of Linux running in there. Anyone know why are we seeing an increase in like recent deployments in space? Anyone have any ideas? You? Come on, Tim.
Lower cost to orbit.
Lower cost to orbit, that's exactly right. I grabbed this really nice chart thingy from a blog post. I'll share the slides so you can get the data source to go to the blog post. But this is why. This is the reason why. So basically, everything leads to more launches. Improvement in technology. Yes, Linux is a big factor here. Lower energy consumption. Higher public customer confidence. Huge factor. Increased safety reliability. Lower development costs. Cheaper, faster launches. Cheaper payloads. And then my favorites, which is the wider spectrum of like reasons to actually have something in space. Eventually tourism. I don't know. Infrastructure, manufacturing, like data centers in space, things like that, like all that new thing, future-looking stuff will contribute to having more launches. But like Tim said, what actually is driving this is lower cost to orbit. If we go back to 1960s, the cost per kilo was around $12,000 to $20,000 and 20-ton rocket. All the way to 2020, who knows the approximate weight of Starship? 17 tons. So 17-ton rocket is right now estimated in $190 per kilo. That means that if Starship gets mass produced, let's say we got 50, the estimate is like the price per kilo will be like around $60. Imagine that, $60 per kilo. That means that anyone can eventually deploy to space, which will mean that the industry will only grow. This is great because now we'll have more Linux deployments, right? Well, if Linux is already in space and deployments will only increase, then what are we doing here, right? Like, what's the purpose of this? Well, lack of standards hurts the industry. What we're seeing right now is a deep fragmentation in deployments. Yes, you're running Linux, but which Linux version, which flavor? And the reality is that every mission is picking whatever they choose is best for them. This is a quick survey that we did on our SIG. What flavors of Linux are you actually using? The majority is using Yocto, but surprisingly, there's people using Android. Artems, Zephyr, Arch Linux, FreeRTOS, others that are not pictured here, QNX, Buildroot. So the reality is that most missions are one-off designs. We're not yet into era where there's mass-produced deployments out there. No portability between missions. This is one of the biggest factors that is hurting the industry right now. No cross-vendor knowledge transfer. What does this mean? That there's not a really good ecosystem of vendors out there that are actually sharing standards between them. Let's talk about the space considerations, space environment considerations. So for a mission, right now, everything, like I said, is one-off. So it's very mission-specific, like maybe Ingenuity. Let's take it as an example. They needed to have a drone in space, and it's not mass-produced, it's just one-off. So it doesn't really matter that the code that I deployed there is not very good, or not, it shouldn't say very good. It's not readable for other developers because it matters that it runs and that this developer that is doing this is focused on this, right? It works for me, maybe not for the other mission, or the other developers might not like it. Substantial investment in creating this out there, so it's not something that you can replicate easily. And then there's assets that require a lot of security. And there's obviously a reliability guarantee requirement here. Generally, for space, you need to have no traditional networking. That means that communications are delayed. There's a lot of loss of signal happening, and it's very slow. So connecting to something in space is slow. But the structured command and telemetry, let's say for mission control, right now, the reality is that you almost have to be a system administrator type of persona to be able to manage one of these things. So we need to go beyond that. Like, not everyone in mission control is a sysadmin, so we need to fix that. And then other considerations, which are the biggest concern to especially Linux right now, is radiation-induced single event offsets, power constraints, and NAND bit flips. So, all right, we got faster deployments. We got Linux in space already, but we have fragmentation. How do we fix this? Well, this is where the human factor comes in. What's the main characteristic of open source? Can anyone tell me? We're an open source summit, come on. The community, yes, all of you, yes. So this is why we're trying to do open, space for Linux. It's a space distribution, Linux distribution for space. We're trying to enable an ecosystem and a community. Yes, there will be code, there will be a Linux distribution. We're trying to focus on enabling all of these stakeholders to make sure that there's a shared distribution that supports all of the different use cases, autonomy, satellites, eventually flight systems. So right now we're using Yocto as a layer. We have a skeleton layer. We're trying to do a multi-layer approach similar to what AGL is doing. We have a base minimal layer, we have base configuration, have an MIT license, and a developer certificate of origin combination. And we're planning to support different user space applications, which I will be talking in a few slides, and obviously hardware support, which is interesting. What are the primary mission objectives? Reduce the cost, reduce errors, stop reinventing the wheel. Like I said, things shouldn't be specific for one mission. There's a common element across missions, which is like you need an OS, you need it to be safe, you need to be radiation resistant. So you need all those things in there as a base configuration. That's what we're trying to enable. We're going to inspire more confidence in Linux. The reality is that even though it's being deployed, there's still a lot of people that don't want open source in their missions. So as part of Linux Foundation, we're trying to evangelize, trying to make sure that they understand license compliance and making sure that they understand how the community and open source contribution processes work. So establishing a trusted ecosystem, demonstrating reliability outside of terrestrial applications, have just a baseline for future certification. Hopefully we can be talking about that next year. And then, yeah, just basically making sure that the base OS layer is ready for the next gen high performance hardware. Okay, so what is actually being done right now? So we have a meta SGL repository with a skeleton layer for Yocto. Our early focus right now is to selecting the kernel features that would allow us to be resilient to user single upset space events, and gathering mission requirements. So we're working with different groups that are already deploying with Linux in space and making sure we capture all those requirements. The key themes that we're addressing right now, like watchdog and fault detection, file system reliability, bootloader and startup integrity, over the air updates, so I guess over space updates, bootloader and startup integrity, traceability, and then all the user space applications. What are the user space applications? Does anyone know about CFS or F prime or SpiceROS? Tim again? All right, so these are the most widely used user space apps in space. So like Ingenuity was running F prime. They're basically applications that have a collection like middleware modules that the different missions utilize to be able to achieve autonomy. And those have requirements. So we're trying to capture what those requirements are, make sure that we bundle those requirements within the base OS layer so you don't have to recreate that layer on top of what we're doing already and have to spend the time doing that. So we're capturing requirements. Hopefully the first demos for SGL, like you'll see at the next OSS, will be having hardware in the loop with one of those apps running, and you'll have a nice simulation and you can see that. What is the hardware that we're actually targeting right now? This is like a Raspberry Pi type of device. It's a RISC-V based. It's a very affordable, and we're choosing this so that everyone in the team can have it, and we can deploy and test easily. Did you get yours, Tim? Not yet? Yeah, likewise here. So roadmap-wise, what do we actually have and what's next? What's coming? So we got a skeleton layer, which means the Yocto thing is already, skeleton layer is down. We've got CI and CD pipeline. We got the build structure already done. We got documentation, initial documentation, I would say. We got all the nice things like the framework. You push and commit and gets deployed. But it's a bit rough around the edges. It's not everything's covered. We need to invest a lot in having better docs. SBOM generation, it's not that we don't know how to do it. It's more that we're waiting for other steps to be done so we're to be able to bundle this with the artifacts. Footprint and tracking and analysis. So this is something that we're taking into account when we're deploying hardware. We want to make sure that we know exactly what's in there. Test on hardware deployments. As soon as we get the hardware set up, we're going to start doing that. We've been talking with a lot of research groups that are doing radiation testing in Linux and hardware. So we're taking those considerations into account and hopefully build them into test cases that will be running in CI so that we ensure that Linux is building and is resilient to those. And the user space layers of the CFS and F prime stuff, and we bundle that, and then we get a demo. So there's a lot of work that needs to be done. So if all the people that raise their hands that were interested in working with space, you can help us. So where is this work happening? This work is happening under ELISA. The ELISA project is a project that is working towards enabling Linux and safety applications. They're incubating the Space with Linux SIG for us. They're helping us, giving us all this structure for Linux Foundation project. We got monthly meetings via Zoom. We got mailing list. We got a Discord server we can interact. We get a repository where we actually put all the meeting minutes and all the roadmap discussions and all of that. And then we also host the Meta SEL repo with all the code. And then we also host in-person workshops. We had one in December at NASA Goddard. And these are some of the companies that are actually helping us, more than 20 already. You got people like Boeing, Cesium Astro, Wind River, Red Hat, NASA, different NASA groups. And yeah, we're hoping to recruit more as we go. These are some of the first enablers. We had a first workshop where we actually defined the first things that we were focusing on, the roadmap and all of this. This happened December 10 last year at Goddard. We had 30 people show up from those group, and then more than 40 virtually. The presentations, slides, and everything is already on the ELISA website. So you go elisa.tech, you'll be able to find all that info. And yeah, based on this work, we actually put everything together. Just a quick picture of us. If you can find me. Yeah, I'm in there. All right, so where are we right now? Where can you contribute? We have beginner-friendly getting started page. That's a huge need. It's kind of rough right now. I mean, we're developers, right? How rough can it be? It's rough. How to make a simple recipe, like all we joke to people in the room. Maybe you can help me with that. Hardware-specific docs. We are supporting the BeagleBee Fire, yes, but maybe having specific docs for how to enable it, how others can purchase the hardware and test it. How to flash the hardware porting guide. Maybe actually, me and Tim, we don't have a BeagleBee Fire, but we do have a CM4 laying around. Maybe you can help us port to that. Footprint analysis. And then lastly, radiation hardening. So I guess our biggest question in the group right now is how does radiation actually affect Linux? We were talking to researchers at BIU last week, and they were sharing a lot of the research they are doing. They're finding out that actually hardware gets widely more affected than the actual software. And there's a lot of things in Linux that can actually be done already to harden your deployments, like memory scrubbing, enabling ECC. But we need further validation. Like, we cannot just take it for granted. And yes, contributions are more than welcome. I'm going to do a quick recap, and I have some more data to show you if you want to. Intent to create a Linux distribution in space. That's what we're trying to do here. It's like very early stages still. We've been doing this for the last 12 months. Things are slow, but space, you'll notice that it's very slow. Like, everyone goes at a very slow pace. But it's because they want to make sure that all the requirements are captured before we start developing. We're intending to actually spin off out of ELISA, make sure we have our own foundation project, own governance. But first, we're incubating in ELISA, making sure we have the funding to actually develop this. Anyone can join the project right now. You got ongoing research through the coordination meetings, the monthly meetings that are happening. Hopefully, we're going to move those to bi-weekly as more people join us. And yeah, we got the first steps, skeleton layer, build system, we got CI, we got docs, so we're ready for contributions, and we really would appreciate those. You can scan this, go to the actual docs, so you'll see I'm not lying about being a bit rough. And then you got the repos over there. The Meta SEL actually has the skeleton layer. The SIG one has the meeting minutes on roadmap discussion as an issue, then Discord, and the mailing list. Everything happens through the mailing list, so that's the one you want. All right, thank you. I can take questions, and I can also show you survey answers from what we did, which are very interesting if you want to learn about that. Do you want to do the survey, or do you want to do questions? Data? All right, yes, data. All right, Tim already knows this. So we actually ran a survey through the people that attended the workshop and other people that were interested in the mailing list. This was really early, so that's why we don't have too many responses. I think we'll want to open a new one because there's been a lot of people that have been recently joining, so we want to have more responses here. But from the people that joined, like, they were from automotive, aerospace, and space. Mostly from space, which is good. You're currently using Linux? Mostly yes, but not all of them. Which areas are you mostly interested in? Bootloader, remote updates, kernel configuration, user space simulation. Any surprises here? Is this what you would assume that someone wants out of Linux? I didn't find it surprising. That's actually what I thought would be what they would be interested in. For space aerospace, are you currently deploying unmanned, manned, mostly unmanned, so which means autonomous? Which of the following distributions are you currently using? Let's already show you this one, mostly Yocto. I guess the better question was like which Yocto versions, right? For space aerospace, what is the expected development life cycle? Which means like once you deploy, how long like does it get to live? 1 to 3 years is the usual response. It's rare that it's more than a 5. What is the, oh, sorry. Okay, development. This was the development one. How much time does it take to develop? This is the one that's how long does it actually live, the mission life cycle is. More than 10 years, 5 to 10 years, 1 to 3 years, less than a year. So it's like kind of varied. Like there's a lot of each one of those. Which of the following system daemons are we currently using? System D is king. Which of the following standard libraries we got? glibc, topping each other, the other ones. Compilers, GCC. There's some Rust in there, so it's interesting. How is your target OS assembled? Mostly through an open source bundler installer. If custom, they have like embedded cross builders and manual compilation processes. This is where we took the most data for the Userspace applications. What actually are you using with Linux? So SpaceROS, CFS, other F prime, and there's like the list of the other ones. Which of the safety security standards do you actually need to conform with? Any surprises? No? Are you currently using any of the following security practices? SBOMs, kernel security hardening, managing orchestration, and you can stop me at any point. System design elements, hypervisor, watchdogs. When it comes to radiation hardening, which is what I was informing our decisions here, is like, which of the following is more important to you? So ECC, patrol scrubbing, hardware, watchdog, writable mass storage, redundant hardware, RAM-based file system, writable storage. Like pretty much everyone selected everything. Yeah, that's what it means. Which of the following hardware architectures do you need to support? Based mostly ARM. Happy to see some RISC-V in there. Not sure what's happening with Spark and PCC, but yes, it's out there. Please mark the hardware platforms that you're planning and currently using. Interesting, some space cubes in there. NVIDIA Jetson, so like off-the-shelf commercial hardware. Chillings, AMD Versal stuff, QEMU, Raspberry Pis. So yeah, all across the board. HPSC, for those of you who don't know, it's the new hardware standard by NASA. They're trying to push for high compute processing power. Are you planning on currently supporting AI, machine learning? It's like the hot topic, right? So the question is which libraries you're actually using. Not surprising, like I guess the usual suspects. Any other libraries that you need to support? I guess it's the same as before. And that's it. All right. Enough of the data. I'll take questions now. Go ahead. Be nice. You got a sticker.
You had a slide with how long they plan to run their system.
The operational life cycle, yes.
Do you think they are like Voyager or Mars rovers? They were planned for a short time and running since ever?
Yes, the question was, do I think that people were lying when they answered the operational life cycle question? Yes, but I think they're being optimistic, like they're not pessimistic about the mission cycle. So they have the target, and then anything they got on top is extra. So I think that's how they operate. Same thing happened with Ingenuity. It was planned for 5 flights, and it lasted over 50, I think. Yeah.
Sorry, that's interesting. Isn't that like in the life cycle for that need to do installs and stuff? Because I mean, once it's launched, then you're not going to do over-the-air update.
Yes, that's the question was. Yeah, the question was about the updates for a longer mission, right?
So they do over-the-air updates after launch.
Yes, they do. There are missions that do updates, not all of them, and those are some of the considerations that we need to take when we're building this. Yeah.
Even worse, sometimes they launch a system without all the software they need to actually land on the planet. I've seen it often.
Yes, he's gentleman was saying that there's missions that ship without the actual critical software that they need for the mission, and that seems doable. Tim, you were saying?
Well, I was just going to comment that low Earth orbit, right, decays in about 5 years, so they don't worry about updates so much. Although SpaceX notoriously does a lot of updating of their software.
Mm-hmm.
But like deep space, we haven't seen Linux in deep space a whole lot yet. Just like only like 4 or 5 projects have gone out of low Earth orbit with Linux.
Thank you. Go ahead.
How do you deal with when you're creating some standards like this? Aren't there very, very different requirements for something like the drone helicopter thing?
Yeah, Ingenuity.
Ingenuity versus like a module for the ISS. Like, isn't that
Yes, there's.
very different?
Yeah. So the way we're planning to do this is by having different layers for the distribution. Like you only use what you need. So the base common layer is going to have all the radiation hardening and everything, and then there will be optional layers that you can bundle on top of this, depending if you're doing autonomy or if you're doing like a automation service. Yeah. Gentleman in black.
So the hardware that you chose was Beagle Fire.
The Beagle B Fire. Yes.
Yeah, and this is RISC 564
Yes. Is respect.
microchip that is hardened for radiation.
I believe it is, right, Tim? That's why we used it, or no? I don't think it's hardened, is it?
I don't know if it's been hardened.
Okay. We don't know if it's hardened.
Microchip is known for hardening.
Yes, but this specifically, we're not sure. I think right now, Microchip is focusing a lot on the HPSC standard line of hardware, but the Beagle B Fire, I'm not sure if it's hardened or not.
Yeah, but my question is that RISC 5 with Geisler and with ESA also, they have a lot of RISC 5 based SOCs because
Yep.
these have to be custom made kind of because of mixed criticality. So
Mhm.
hardware also you have to handle that. So the stack that you are trying to develop in Yocto for this will be based upon Meta RISC 5 and this. This is how will the below layers that you are planning to use in the Yocto subsystem, if you can maybe tell us more about why did you choose this specific thing and how do you want to go ahead with this? Will it be ARM based or it will only be Meta RISC 5? How will it be?
No, well, we chose it because it was the most affordable space-like hardware, like a Raspberry Pi, because we wanted something for fast prototyping, basically to enable fast development cycles. How do we plan? What the hardware strategy will be is let's see what the actual mission requirements are. Right now, I just came from a space conference in Los Angeles, and it appears to be that the HPSC standard is going to be the future hardware choice, which is RISC-V based. But we're not going to lock ourselves to just RISC-V. Like if there's still a lot of ARM, we're going to continue to support that as well.
There is no ARM vendor who hardens. As of now, I don't know that any ARM vendor hardening the.
You want to take that, Tim?
Well, yeah, but a lot of Raspberry Pi is going up into orbit anyway.
Yeah.
and like SpaceX is using hardware duplication for mitigation strategies. So they're using commodity processors, and basically they're using voting algorithms and triple module redundancy and stuff like that. So they're not. A lot of low Earth orbit stuff is not actually radiation hardened.
Yeah, for the video, what Tim was saying is that people are actually shipping Raspberry Pis to space. Over there?
My name is Andreas Tiller. I'm the actual Debian project leader, and I'm a little bit depressed about the low usage. What
Yeah.
can Debian do better to get used in space?
To use what, sorry?
To be useful in space missions.
Well, working towards a Linux distribution, like the standard, let's have this standard image. This would help a lot to enable different missions. Like this is the biggest pain point right now in the industry. If you talk to developers, like the OS level things is like a biggest pain point for them. Yeah.
Have you had any, and do you expect nation state actors to be involved in creating this, or is being involved?
Yes, hopefully the state agencies join ELISA and as members, so they can contribute. there's already, I should be careful what I'm saying next. There's already a lot of response from groups that are close to them and people that we know that are looking to see where we land so they can start contributing. But yeah, so like you saw, one of them hosted a workshop. So yes, they're looking into this. They're interested. Over there, yes? That's a good question. So like AGL, you mean? Yeah, it would be nice if we could share more with AGL, yes. It wouldn't be wrong to do that, no. I think the base level requirements and configurations are a bit different. So that's why we're starting with our own thing. But we're following the footsteps of AGL, basically. Everything they're doing, we're trying to replicate here. Basically recreating the ecosystem and community effect that they did. Yep. Another one over. Nice. Let's talk. Maybe you want to join us on our next meeting. Okay. Yeah, just for the video, he confirmed Linux is being used in space, and we're awesome. Sorry that I didn't capture all of that. Question?
So I saw your roadmap, and maybe I missed something. Are you planning to do any software security or safety compliance in the roadmap?
Yes. Yes, the roadmap is ongoing work right now. We want to first see what the actual requirements are before we put it in the roadmap. We actually want to know what we have to do with safety.
But don't you see because what I know in the space every specialty has their own standards. European has their own, and the US NASA has their own. So problem before you are going to comply.
Yes, so I think there's still a long road for us to get the distribution that gets certified, but the missions themselves can do that, and we're looking for a mission that wants to bring this to certification through the process and see what they want to choose, what they choose to do, so we can support them and see how we can support them from the base layer. Yeah, Tim, you wanted to add anything there?
Well, okay. I'll just toss out.
Can of worms.
So there's these tiers of safety certification, with band being the highest tier, right? But somehow those tiers get relaxed in the face of cost. And so, I mean, SpaceX is running Linux on Dragon, right, which are manned missions, and Linux is not meeting the safety, all the safety protocols that NASA has had for decades, right? So I don't know how they manage that, but they're just making it work. So I don't know what does.
Yeah. All right. Last question, Pierre.
Do you have some open position to join the project?
Yes, we need lots of contributions. Yes. All right. Anyone else before I go? Sorry. Yep.
Could you maybe elaborate more about the utility of that?
Do you want to take that, Tim? The variability of QEMU as a platform?
Yeah, we're actually looking right now into doing simulated radiation fault injection in QEMU. There was a PhD student at MIT did something a couple years ago that we're looking at. But if anyone is a fault injection QEMU person, please come talk to me.
Yeah, we're looking for you.
We're looking for this.
Yeah. All right,
We're not experts at that.
the very last one.
Yeah, thank you. Just curious, in one of the slides you mentioned or you showed a bar graph with hypervisor
Mm-hmm.
scoring pretty high.
Mm-hmm.
How does a hypervisor play into this?
That's actually a good question. We don't know yet. We're
The redundancy you have to have, if you are now planning to handle it in software, right, you will have to have two different VMs. If one crashes
Yep.
and other, you will have, in automotive we do the same.
Mm-hmm.
All the safety applications are on one,
Yep, that's right.
on one VM that has a different criticality, and then there's
Yeah.
another VM that.
It's a multi-VM setup. Yep. All right. Well, thank you so much, and I hope to see you in my keynote tomorrow.